Jai Shri Gurudev. Our next lecture video in the problem number 2 and problem number 4. Just go through the problem number 2. It's a square prism of sides of base is 35 mm, axis 60 mm, rest on HP in one of its corner of base is resting on HP. One of its corners of the base is the corner condition. The axis is inclined to HP at 40 degree and the axis is appeared to be inclined to VP at 45 degree. Now from this, which the problem comes under which method it is given the third position. The axis appears to be inclined to be VP at 45 degree, means it comes under normal or direct method, because the word appear as it is you can draw it. As you know, there is a type of solid is a square prism. Base is given of side 35 mm, the base is square and also top also is a square shape it is, right? The axis is 60 mm. Resting on one of its corner, take any one of its corner, always take the corner on the right side of the solid, right? Then axis inclined to HP at 45 degree, that you can show in the VP, and the axis appears to be inclined to VP at 45 degree, that you have to show in HP. It is a word appear is there, then it comes under normal or direct method. Try to solve this problem. Then in problem 4 also is a square prism is given. The sides of base 35 mm, axis 60 mm. Now resting condition, rest on HP on one of its edges of the base. It's a edge condition, is rest on HP. Start the problem on HP. On what condition it is? Edge condition. The resting edge should take on right side of the solid. Now the axis is inclined to VP at 45 degree, second position. Same, the axis is inclined at VP at 30 degree. Now the problem comes under which method it is? Beta or locus method. Why it is beta or locus method? In the first position, the axis will get true length of the axis will get in front view, and in second position front view also will get true length, but in top view, second position top view, what the axis is the reduced length, that is the apparent length. That apparent length is inclined to VP at 30 degree, means it comes under what method is a locus or beta method. We know how to solve this problem, right? Now we'll move on to the next problem. Problem number 5. A pentagonal prism 25 mm sides of base and 60 mm axis length rest on HP on one of its edges of the base, which is inclined to VP at 30 degree. Draw the projections of the prism when the axis is inclined to HP at 40 degree. Now read the problem once or twice, then write the given data. Now what type of solid is given? It is a pentagonal prism. Pentagonal prism means what? The base means bottom face and top face having what shape it is? Pentagonal shape, is a regular pentagon. What size it is? 25 mm sides, right? Or how do you connect this base and top face? With the help of rectangular face, that is called as a prism. What type of solid is given? It is a pentagonal prism. Sides of base is how much? 25 mm. The base of the sides is how much? 25 mm. All the sides are equal, is a regular pentagon. And the axis is 60 mm. From the top base center and bottom face center and top face center, what is the length? It is 60 mm. Now what is the next one? Resting condition. Rest on HP on one of its edges of base. Resting where? Rest on HP. We start the problem on HP. Which condition is rest on HP on one of its edges? Means edge condition is edges of base. Now consider any one edge. Now I'll consider here resting edge. I consider is a C1, D1 is the resting edge. Now resting edge inclined to VP at 30 degree. This is the third position actually. The third position condition it is. Now axis is inclined to HP at 40 degree. This is second condition. In third condition, see the edge, resting edge, that will never changes with the dimension. That's called as normal method, right? Now we'll see the how to solve this problem. Now as the given data is a pentagonal prism, sides of base 25 mm, axis 60 mm, rest on HP. On one of its edges of base, we start on the HP. The resting edge should take on the right side of the solid. Then condition, second condition is the axis is inclined to HP at 40 degree, resting edge inclined at 30 degree, VP at 30 degree, right? Now where you want to start? First draw a horizontal line, then name that line as a XY line, and above X line is VP, below X line is HP. Now where you want to start the problem? I want to start the problems on the resting condition, rest on HP. The solid is rest on HP, we will start on HP. On one of its edges of base, always take the resting edge on right side of the solid. In planes we consider left side, but in solid we consider on right side of the solid. Now you know how to construct the regular pentagon, right? How do you construct? First draw a vertical line. On the vertical line, how much? 25 mm we measure. From the vertical line, what is an, as you know that the excluded angle of the pentagon is how much? 360 divided by number of sides of pentagon 5, we will get how much? 72 degree, right? Here also it is how much? 72 degree. Draw a 72 degree on the both side of that line, corner of the line. On the 72 degree line, measure how much? 25 mm through compass. Take the radius as it is 25 mm through compass, then draw an arc. Then draw an arc on the 72 degree line. We'll get two other corners. Again from that corners, again 25 mm radius, draw one more arc. Then you'll get the intersection point, you'll get one more corner here. Right? Now is the regular pentagon. It is a continuous thick line, and it has two faces. One is bottom face, another one is top face, right? Bottom face we name it as A1, B1, C1, D1, E1, and top face is A, B, C, D, E. Now bottom face corners are invisible, that's why kept in bracket, right? And also show the dimension on any one side. It takes draw a line parallel to that edge, show the dimension, and that completes what? First position, top view, right? When you view from that observer in front of that object, now you can see in the front view, right? Bottom, then project all the corners of the pentagonal prism, bottom face and top face corners vertically upward along that vertical line. So measure how much axis length is given, 60 mm, right? That is O is the top face center, O1 is the bottom face center. Draw vertical projection from each corner and the center of the base and top. Then on the along that line, how much you measure? 60 mm. Now you get the bottom face corners here. From viewing from observer here, A1 dash is visible, B1 dash is visible, E1 dash is invisible, that is coincide here. Then O1 dash is visible, C1 dash is visible, D1 dash is invisible. There is a bottom face corner. Similarly go for top face corner. Now that completes what? First position, top view, right? Now what is second there is a first condition is over, right? Resting condition is over. Next, second one condition, axis is inclined to HP at 40 degree. Whatever the dimension given to the HP, that I want to show in VP, right? Now the axis, this axis is inclined to at 40 degree, that I want to show. Whatever the dimension given HP, that I want to show in VP. Directly I can't get this. Now we'll call it, this is a base. What is the base angle? I'll call it as a theta. Is a 9. This is a right angle triangle, right? This is a 90 degree, right? I want theta. Theta is equal to 90 minus of 40. That is equal to how much? 50 degree. The base angle is, that is theta, is 50 degree. Now is the resting edge what? C1, D1 is a resting edge. The mark the point on the XY line, C1 dash, D1 dash. Then draw through the protractor, draw a 50 degree line, theta degree line. On the theta degree line, just place this base edge on the theta degree line. I think you know about how to place this by using compass, right? C1 dash, O1 dash, C1 dash, O1 dash. Similarly C1 dash, B1 dash. Then take the compass, C1 dash, B1 dash, B1, C1 dash, B1 dash. Similarly C1 dash, A1 dash, the compass, radius, C1 dash center, A1 dash on the theta degree line, 50-degree line, right? Then from that all the corners draw a perpendicular lines or 90-degree lines from those bottom face corner, right? Along that perpendicular line, 90-degree line, how much it is length it is? See that this is 60-degree, right? Just you rotate this square, sorry, pentagonal prism, and through how much angle it is? 40-degree, right? Now on the once you draw here 90-degree lines from each corner, measure 60 mm, then draw here and make it is visible thick continuous thick line, right? Then C dash, O dash, B1 dash, A dash will get. That completes what? Second position, front view. When observer view from the above the object, we draw all the vertical projection, okay, towards downward, and from first position top view draw all horizontal projector from the corners of the prism, right? See that A1 dash vertical projection, A1 horizontal projector, that meter code as A1. Similarly B1 dash vertical projector, B1 horizontal projector, C1 dash vertical projector, C1 horizontal projector, D1 dash vertical projector, D1 horizontal projector, E1 vertical projector, E1 dash vertical projector, E1 horizontal projector. Just you make it, mark that points, don't join those lines or edges, just mark the points A1, B1, C1, D1, E1. Similarly O1. Similarly on top face corners also draw vertical projector and then a horizontal projector, name it as A, B, C, D, E. Now how do you join those corners? Remember those 4 points, all outlines are thick lines, right? What are the outlines? A1, B1 edge is there, B1, B1, B also edge is there, B to C edge is there, C to D, D to E, E to E1, E1 to E1. Those are edges are there, all outlines are visible, continuous thick lines. Next, remember second point, when observer here, right, top is that viewing the above the object. Now A dash is near to the observer, means what is the corner is? A is visible. Corner A is visible, the edges which is passing from that corner is also visible. There is a continuous thick line. What are the edges? When corner A is visible, A to E edges is there, top face edge, A to B also top face edge is there. Then join these two corner, then you get a edge, is a visible edge, continuous thick line. From A to A dash also rectangular face edge, right? That also there, there's a continuous thick line. Then see that observer, now C1 dash, D1 dash are, it is far, those corners are or edges are far away from the observer. Now D1 and D1, C1 and D1 are invisible corners, is far away from the observer. That's why these two are invisible corners. The line joining the edges form these two corners are invisible edges. C1, D1 is invisible edges or corners. C1, D1 invisible corners. The edge forming also invisible. That's why we show the dashed line. Then what are these invisible corner? The edges which is formed from the invisible corner also invisible edges. D1, E1 edge is there. C1, B1 also edge is there. That is a dashed thick line. Similarly D1, D rectangular face edge. C1, C also rectangular face edge. Those are also a dashed thick line. Then O1, O is the axis line, but that is coincide with A and A1. That completes what? Second position, top view, right? Now that completes the second condition. What is the third condition? The resting edge inclined to VP at 30 degree. What is the resting edge here? In first position top view, resting edge is C1 D1. In second position top view also, what is the resting edge is C1 D1. Is there any dimension changes? No, this dimension is how much? 25 mm only. Now that resting edge inclined to VP at 30 degree. Whatever the dimension given with respect to VP, that I want to show in HP, right? Draw a 30 degree line. Draw a line parallel to the XY line. In that, draw a 30 degree line. On the 30 degree line, which is the resting edge, C1 D1 is the resting edge. Just place C1 D1, right? Once you know these two corners, C1 D1, the dashed line, Then how do you place remaining corners? That's very important. Now when you rotate this solids kept on 30-degree line, see that once you place D1 C1, now what about E1 A1 B1? That will come below the 30-degree line, right? Then how do you place this? How do you place these corners? Take C1 B1 is a radius, that is equal to D1 E1. C1 E1, draw an arc, that is equal to D1 E1, draw an arc. Then we know the C1 E1, that radius through the compass, that is equal to D1 B1. Then C1 E1, draw an arc, that you get intersection point. Then D1, draw an arc one more this side, you get intersection point, that is B1, right? Next we know the C1 A1, that is equal to D1 A1. Then C1 A1, draw an arc, that is equal to D1 A1, draw an arc. Now we'll get E1 A1 B1. Mark the points, just mark these intersection points and name it, don't join that. Then from all the corners D1 C1 B1 A1 E1, right, you get these corners. Now you can see that from the corners. Then how do you get this top face corners? Just see that these are all parallel lines, right? These are all parallel lines. Just from the D1 draw a line, 90-degree line to the 30-degree line, right? Draw a line which is perpendicular to 30-degree line from the each corners. Those lines are parallel to each other, right? Once you draw a line perpendicular to 30-degree, there's 90-degree to the 30-degree line. Along that line just measure any one edge, rectangular face edge. Take C D1 D, that is equal to all the rectangular face edges are the length is same. Then take D1, then draw a arc on the perpendicular line, 90-degree line. Similarly E1, similarly for A1, from the A1, from B1, from C1. Now you'll get that D E A B C, right? This is the easiest method to get a top face corners. Then apply this, just replace the second position top view, just place on the 30-degree line. The what concept is same concept you can apply here. That completes for third position top view, right? Once you complete third position top view, then project all the corners and towards vertically upward, and from second position front view draw a horizontal line from the each corners of the pentagonal prism from base and top also. So consider first base. Now A1 vertical projector, A1 dash horizontal projector, the intersection point is A1 dash. Similarly B1 vertical projector, B1 dash horizontal projector. Similarly go for all the corners for the base and also top face, right? Now once you get all the in the third position front view, once get the intersection point, then once you get the corners of the base and the top, then how do you then you go for apply the rules, visible and invisible lines. How do you apply? For all the outer lines are visible, outer edges are visible. Now you can see the E1 dash D1 dash visible is a outer edge is there. D1 C1 dash D1 dash C1 dash, C1 dash to C dash edge is there. C1 dash to B dash, B dash to A dash to E dash to E1 dash. First make all outlines of the solids are visible, continuous thick line. Now here observer, now which is the corner nearer to the observer? A1 B1 corners are nearer to the observer, that edge also near to the observer, that is visible. Now that is A1 dash, the corner is visible, B1 dash also the corner is visible. Then join those two corners, that is a visible edge, and the edge which is passing from the visible corner also visible edge, B1 dash C1 dash A1 dash E1 dash, right? Then B1 dash B dash visible, A1 dash A dash also visible. Now what are the corners which are away from the observer? See that corner D. Yes, corner D is a invisible, is a far away from the observer, that is a D dash is invisible. The corner D dash is invisible. The edge which is passing from the invisible corner is also invisible edges. This is D1 dash, C1 dash, sorry, D dash, invisible corner, invisible edges. D dash, E dash also invisible edges. Then D dash, D1 dash invisible edges. There's a dashed thick line. Then as you know that O1 and O, that axis line is, one is long line, another short line, right? That completes third position, top view, right? This is the problem for number 5. Similarly, go for try the problem number 8. It is also a pentagonal prism. Side of base is 25 mm, axis 60 mm. Rest on HP on one of its corner of the base, resting on HP here. With what corner resting on one of its base, corner of base is a corner condition. The axis is inclined to HP at 40 degree, the second position. The same axis is inclined to VP at 30 degree. Now which problem it is, which method it is, beta or locus method, right? So similarly try this problem. You can see that in this problem is a pentagonal prism, 25 mm sides, axis 60 mm, rest on HP on one of its corner, that take the corner on the right side. How do you know the construction of the pentagonal lamina? They take the resting edge on the resting condition on the right side. There's a resting on corner. Just draw a vertical line here. From here, you know how to construct the exterior angle is 72 to 72 degree. On the 72 degree line, mark 25 mm. Then to the compass, take 25 mm radius, draw an arc. You will get this corner, right? And name the bottom face corner and top face corner. Then first position, top view over. Then project it first position, front view also you will get. Then second position. Now is given condition. What is the resting condition? Rest over, axis inclined to HP at 40 degree. Whatever the inclination given on the HP, that is showing VP. That is 40 degree. The base angle theta is equal to 90 minus 40. That is 50 degree. Now just replace this first position, front view, in on the 40 degree line. That is second position, front view over. Then project it. All vertical projector, horizontal projector will get the second position, top view. Now the interesting is the axis is inclined to VP at 30 degree. Now the interesting is the axis is inclined to VP at 30 degree. Now it come under the axis inclined to VP at 30 degree. That is a beta locus method. As you know that up to second position, okay, top view over, right? Now see that axis in the first position, axis in the front view is 60 mm. In second position, front view also it is 60 mm. When view from here, the axis O1 O is now become reduced length, that is 45 mm. Now this 45 mm I want to place where VP at 30 degree, means whatever the dimension given in VP, that I want to show in HP. Now draw the 30 degree line. On the 30 degree line, if you directly place 45 mm is wrong, because up here word is not there. Then it comes under what? Beta method, right? Now once it beta method, first draw a 30 degree line. On the 30 degree line, what's the true length of the axis? The true length of the axis is 60 mm, right? Mark the on the 30 degree line, mark any one point O1 and draw an arc 60 mm radius on the 30 degree line. That O1 O you get how much? This one is 60 mm. From that O, draw a locus of O, right? Once you draw the locus line, then what is the apparent length? Axis length is O1, O is the apparent. How much you get? Almost 45 mm. Then take the compass, 45 mm radius, O1 is the radius, draw an arc 45 mm radius that touches the locus of O, that is gets second position, top view, that O here. Now this is O1 O, that join the line O1, extend that line is called as a beta. How much you get? 41 degree, right? Now on the O1 O, this axis beta degree line, we place this solid on the beta degree line. First you place O1 O. After once you place O1 O, now what are these? A bottom face, there's a base corners are there, just transfer here. How do you transfer? As you know that O1 A, we know the radius, O1 A, draw an arc, that is equal to O1, B, draw an arc. O already we know that O to A1, O to B1, that is the radius is same. Then draw an arc from the O is the center, O1 A and O1 B. Now we'll get the corner A1 B1. Similarly, O1 C, that is equal to O1 E. O1 C, draw an arc, that is equal to O1 E. Then O2 C is the radius, O2 C1 is the radius, O C1 is the radius, O E2 is the radius. O to C, draw an arc, O to E, you'll get C1 and E1. Similarly, on the O1, O will get D1, right? From O1 to D1, measure it, O1 to D1. Now we'll get the corners, bottom face corners or also base corners A1, B1, C1, D1, E1. Now you know how to get the top face corners. From the each corners, draw a 90-degree line or draw a line which is parallel to O1, O from the each corners. Along that line, how much, what is the measurement here? What is the O1, O is there, or else you take any one, resting edge, A to A1, rectangular face edge, A to A1, that is equal to B to B1, C to C1, D to D1, E to E1. Take one corner A1, draw an arc on the line which is parallel to the O1 O. Similarly, B1 B will get C1 C, D1 D, E1 E. Now we'll get the top face corners, right? Just to transfer this second position top view on the beta degree line. Redraw that solids. Now we'll get third position top view. Now we'll go for vertically project it from each corners, and from the third position top view, horizontal projection from the second position front view, the intersection point there. Then apply the concept of visible and invisible corners and edges and lines, right? Try to solve this problem. Okay, thank you for watching this video.